Hello and welcome to SudoKanard. We are here to solve this arrow Sudoku by Ukrainian author Serhii Tyshchenko, and this was featured in the latest Sudoku Grand Prix. And although I had to restart the puzzle twice because of mistakes during the round, it was definitely one of my very favorite puzzles in the set. So the special rule is very common. Whenever you have such an arrow stemming from a circle, the digit in the circle is the sum of all digits along the arrow. So first thing first, and the first thing is that this digit is the sum of all three digits here without using 1, so the minimum value is 2, 3, 4, that's 9, and we can't do it more than 9, so that we have 9 as the sum of 2, 3, and 4. And this is not 4, and the rest of the row is 5, 6, 8, but this can't be 8. Something else of interest is that 9 and 8 must appear somewhere on this row, and the only cells where they can go are those cells. Because, well, if I try to put, say, 9 or 8 here, the sum here will be much more than 9. So that won't work. And because of this 9, this is 8, and this is 9. Now this digit here is the sum of those three digits, and it's not 6 nor 9, so it can only be 7 or 8. 7 will be 1, 2, 4, and 8 without using the 3 will be 1, 2, 5. So 1 and 2 are necessarily in there, accompanied by 4 or 5. Now where do we look? So 9 here won't ever use the 7, so it won't use the 2. 2 can be here, or 2 can be here. And what I'm seeing is that 2 is never in here, and 7 is never in here. So 2 and 7 must be somewhere in the column. And 2 can't be here because of the 6, so 2 will be somewhere here. But this can still be 1, 7 or 3, 5. Except that 8 as the sum of 3 digits must include a 1, and this is true also for this. So there must be a 1 somewhere in here, a 1 somewhere in here. We can remove those places because of this. So we have a 1 in here and a 1 in here, and you can see that this can never be a 1, this can never be a 1. So 8 here is not 1 plus 7, so the 2 and the 7 can only be here in the column, and this is a 3, 5 pair. Now those must all be between 1 and 5. So 9 will be here, and 6 will be here as well. 6 can't be along such an arrow. So we have a 6, 9 pair in here. This is from 2, 3, and 7. And we can see that 5 is somewhere in here. But 5 will never be here, because then those would have to be 1 and 3 is not available. Actually, there are 3 options for 9 as the sum of 3 digits, and those are 1, 2, 6, 2, 3, 4, and 1, 3, 5. And you can see that the only one that doesn't use the 3 is 1, 2, 6. So that those here are 1, 2, and 6. I can remove 1 from here, 6 from there, and 1 from here, so this is the 1. And that is not a 6. And we can see that because of those ones, this doesn't use the 1. So this is 2, 3, 4. That's not 4. And this is not 2 or 4. Now what about this? We can see that here and there we must have the 2 in both cases. So 2 is never available for that. Actually, 2 is somewhere in here. and it will be accompanied by 5 or 6. Something else I'm seeing is that 9 doesn't belong here, so in this column 9 is here. And 7 doesn't belong here because it would be with a 1 here to have this equal to 8, but 1 is not available. So 7 on this column must be here. So that now, oh, actually I could have seen that 7 goes nowhere here anyway, so that has to be the 7, this has to be the 2, and this has to be the 2. This 2 tells us that this is 5 or 6, and in the column 8 doesn't belong here, so 8 must be here. This is 5, this is 6. Seven can't be here. That doesn't seem to be so interesting. So in this column, this is also 1, 5, or 6. 6 here would have to come with 2 or 1, but none of them is available. So that is a 6, and this is finally 8. So that this is 1, 2, and 4, and 5, sorry. And we're left with 4, 7, 9 in here, so this is 7 or 9. Any of them, 4 or 9 here. So what is this? It's not 1 and 8, it's not 2 and 7. It could still be 4, 5, or 3, 6. With this 4, this, so we could have 4, 5 and 4, and 3 and 6, 3 and 6, and no, that's a 6. That's not a 7. Actually, only 5 is available on this row, so this is 4. That's not 4. 4 is here. Here we need an 8 somewhere. It can only be here, and this is from 6, 3 and 6. This column still needs, actually with this can't be a 3, so this is not 5, that's the 1, 5, and this is 7, and the counterpart of this is here. Sorry, that's not an 8, 3 or 6, and that's a 7. Here we have 4 and 9. So where do we go from here? Here we must have a 1 and a 4. But there's a 4 here, so this is 1, this is 4, so this is 8, this is 5. That's not 4, this is 4. So where should I look at this point? Those are from 2, 3, and 6. And actually, there's a 2 here. So this is from 3 and 6. 2, 3, and 6. 6 is in here. So this is 9. This is 6. This is 4. And now 4 doesn't appear in here. So this 8 is 1, 2, 5. So this is from 1, 5. This is from 2, 5. This is from 1 and 2. And this is 1, 3, 4. There's a 4 here, so 1, 3 here. 3, 4, 1, 3 here. And knowing that there is a 3 in here, that's a 2, that's a 3. And, and I don't know what I was about to say. Now on this column, 7 can only be here. That's a 9. And here this is 8 and 9. So 8 here, 9 there. And that's a 4, that's a 9. Here we must have 4, 7, and 8. 4 can only be here. Here we must have 3, 5, and 6, so 5, 6 here. 3, 6 here, 3, 5 here. Here we must have 5, 7, and 8. Can remove, 5, 7, and 9. So 9 can only be here. Here 1, 2, and 8. I think that's correct, so that's not a 2. And I could have found this earlier. Oh, I'm starting to remember that I bifurcated at the end. So here we have a 1, 2 pair, so we are left with 3, 5, and 7. This is 3 or 7. 2, 3, 7, 6. So this is from 2, 3, and 6. No, sorry, 2, 6, and 7. 2, 3, and 6 here. Here I'm left with a 2, 3, 6 triple, which means that this is 1, this is 2. And this is 1. So 2, 3, 6 triple. The only place for 7 is here. So that's a 2, that's an 8. And this has to be a 1. There's a 2 in here, so that's not a 2. And this is the place where I just bifurcated. But if I recall correctly, there is a uniqueness shortcut. At this point, there doesn't seem to be any direct elimination, and almost all cells have only 2 candidates. And if I tried not to put a 3 in here, and this was valid, then there would be no way of disambiguating the 2 options. This is called a bug. And it means that, well, this could only be a 3. And how did I choose the 3? Well, here 3 is the only digit appearing in 3 places. And I'm not sure this is the best way of stating that. But I will try not to use uniqueness and to find a logical way of solving this. So what will it be? Probably a chain, or perhaps it is something like an X-wing. I'm not sure where to look. Oh, sorry about that. This has to be a 4, but this is not how we solve that finally. So is that a chain? It's probably a chain. So scanning for chains is always a bit painful. We must find, it's also called an odogon, I think. Where could it be? So there seems to be something odd in here, perhaps. So 5, 6, 6, 7, 7, 3. This is always painful. I should have scripted this part probably. Or it's just in here. Yes, that's it. That's a very short chain after all. And so, what is this all about? I'm starting from here. This is 3 or 6. So 6 or 3. 3 or 2. 2 or 3. 3 or 6. So, well, what is this all about? It's about the fact that if this is a 6, well, then it's definitely a 6. And if this is a 3, then by that chain we get a 2, a 3, and a 6. So the point is that if this is not a 6, then this other yellow cell has to be a 6. So at least one of the yellow cells has to be a 6, and we can remove 6 from this cell. And now we have a 2-3 pair, and the rest just follows by direct eliminations. Oops. 2, 6, 3, 6. And this 3 makes this a 2, that's a 3, 6, 5, 3, 7 and 5. And with this 2 I get the 1, the 3, the 1, 5, 2, 5, and 3. And that's it. So this ending was a bit more difficult, but the rest of the puzzle was really kind of smooth and very well put. Thanks for watching this video and see you soon on SudoKanard.